Another hybridization scheme is the sp hybridized orbitals. This one occurs when only an s and a p, 2p, 1,2p orbital hybridize to molecular orbitals, leaving two unhybridized p orbitals. You can see the shape change for this hybridization, and what this enables a molecule or an element like carbon to do is form a triple bond, such as acetylene here. Acetylene is a molecule which has carbon triple bond, a triple bond between two carbon atoms, and you can see now that there is one sigma bond from the sp hybridized orbitals between the two carbons, and there are now two pi bonds occurring from the unhybridized overlap of p orbitals. So a triple bond has one sigma bond and two pi bonds, whereas the double bond had one sigma bond and a pi bond, and all single bonds are just one sigma bond. The next hybridization scheme we'll talk about briefly explains the expanded octets that we saw with a sulfur atom when we looked at the sulfate polyatomic ion. We saw that sulfur was okay with 12 valence electrons, and we said that the very close nearby d orbitals come in and stabilize those extra electrons, and they do that through what we're talking about here, hybridization schemes. So for sulfur, it actually entails the hybridization of 1 3s, 3 3p orbitals, and 2 3d orbitals. So we're going to call this the sp3d2 hybridization scheme. And you can see that 1, 2, 3, 4, 5, 6 orbitals are hybridized. And so that allows the overlap for 6 additional electrons, or 12 valence electrons, and 6 bonds for sulfur. And here is SF6 shown here.